Students, so in the last two lecture we have started with the replacement theory, lecture number 14 and lecture number 15. So we have seen the problem in the lecture number 14. I will show you. This is a problem in which we have studied what is the replacement theory. So types of failure we have seen. Then replacement of item whose running cost increases with the time. So where we have seen the time value of money remains the constant as maintenance cost increases with the time, but time value of money remains constant. This type of problem we have seen in the two lectures. Today we will see the time value of money changes. So where we know these are the nomenclature: C, S, RT, then N. C is capital cost, S scrap value, salvage value. In that lecture we have seen the simple problem where resolve value or scrap value is given with the maintenance cost. Then in after that, in the 15th lecture we have seen there is a relation given to calculate the running or maintenance cost, and where we have seen that money value is a constant type of problem. Now today we will see, this is the problem. Today we will see the cost of a new machine is a 50,000. The running and maintenance cost during nth year is given by this relation is given to calculate the maintenance cost, where n is the number of year is 1 2 3 4 up to the n. Determine the optimal replacement age when the money value is constant. So this type of problem we have already seen. So today we will focus on discount rate is at 10%. That means money value changes with the discount rate of 10%. So first we will calculate the average maintenance cost. For that there is a relation given. So relation is Rn is equal to 5000 in bracket n minus 1. So where n is a number of years, so that is from 1 2 3 up to the n number of years. So first we will calculate for first year. So for first year, what is the maintenance cost? So the for relation is 5000 into n is number of year 1 minus 1, that is 0. So for first year maintenance cost is 0. So here I will write the maintenance cost is 0. Then for a second year the relation is 5000, then n minus 1 means 2 minus 1, 2 is second year, 2 minus 1 1, 5000 into 1, so that is a 5000 is the maintenance cost. And for third year the relation is 5000 in bracket, now n is 3 minus 1, that is 2, 5000 into 2, that is a 10,000. So like that you can calculate for a fourth year also. 5000 into 4 minus 1, that is 3 into 5000, that is a 15,000. For next year it will be the 20,000, then 25,000 and 30,000. So this will be the cost we will calculate for the 6 or 7 year. So here I have written this cost. So for first year 0, then second 5,000, then 10,000, 15, 20, 25, 30 and 35,000. I have taken up to the 8th year. So this is average annual maintenance cost. Now we have to see the what is the discount rate and discount factor. So we will see the different columns. So for that, before that we will see, so what is the discount rate? So discount rate is given in this problem. So here discount rate is 10%. So discount rate is 10%. So that is I, that is 10%, or it is nothing but the 0.1. So I value is a 0.1. For that we have to calculate the discount factor. So for calculation of discount factor, so that is the relation is V raised to n minus 1. So what is this value of V? So V is nothing but 1 upon 1 plus I is a discount factor. So here I value is 0.1. So we must know the discount factor is V raised to n minus 1, or V is 1 upon 1 plus I. So here I will write 1 upon 1 plus, now I value is 0.1. So this will become 1 upon 1.1, or if you solve this you will get the answer 0.9091. So here you will get the answer is, I will write here 0.9091 is the answer of a V. Okay, now we have to calculate the discount factor for each year, where n is a number of year. So here similar like this for first year, second year, third year. So we have to calculate this n is a number of year and discount factor. So here for first year, so what is the discount factor? So for first year the relation is V value is, we know that 0.9091. so this is the value of V raised to n minus 1. So here for first year, so 1 minus 1, so that is 0. So this relation becomes 0.9091 raised to 0. So anything raised to 0 is nothing but the 1. So for first year discount factor is a 1. Then similarly for second year 0.9091 raised to, now here n is the number of year for second year, so 2 minus 1, that is 1. So 0.9091 0.91 raised to 1, so this become as it is 0.9091. So this is for second year. Similarly for the third year, 0.9091 raised to 3 minus 1, so that is 0.9091, that is square. So you will get this value is 0.8264. Similarly, you can calculate for a fourth year, so it will become 4 minus 1, 0.9091 raised to 3, 0.9091 raised to 3. So this will become 0.7513. So this is for year number 4. Similarly, you can calculate for the year number 5, 6, 7 and 8. So I will directly put that value in the discount factor. So remain here I is a discount rate, that is 10% is given, so 10% is nothing but the 0.1, and for calculating the discount factor we are having a relation v raised to n minus 1, where n is a number of year. We are calculating for number of year from 1, 2, 3 up to the 8th year. And how to calculate v? So there is a relation 1 upon 1 plus I is a discount rate, so here 0.1. So likewise you can calculate for the n number of years. So I will directly put the value of this present value of a rate of 0.01. so here PV is nothing but the present value, where discount rate is a 10%, or we can say the 0.1. so I will directly write this calculation 1, 0.9091, 0.8264 here, and then we will solve for the further. So for first year discount value is 1, then for next is 0.9091, then next is 0.8264, then next is 0.7513, then next is 0.6830, that is for year number 5. For year number 6, that is 0.6209. For year number 7, 0.56454, and year number 8, 0.513. so this is calculated by the relation. So here I have calculated for 4 year, and next 4 year you can calculate by the same formula. Now next value is present value of f of t. Okay, so present value of f of t is nothing but here present value of f of t into PV. So here we know the maintenance cost is a, I will use another color. So maintenance cost is a 0, and to calculating this column number 3, you can say this calculating column number 3 is nothing but column number 1 into column number 2. So f of t, that is annual maintenance cost, into present value here with a discounted 1 we have calculated. So 0 into 1, that will become 0. Then 5000 into 0.9091. So if you solve this, it will become 4545.5. Similarly here 1000 into 0.8264. so here you will get, sorry, 1000 not, it is 10,000 into 0.8264, so you will get the 8264 answer. Then for next 15,000 into 0.7513, so it will get 11269.5. Similarly I will write for the further, so you have to make the calculation. So column number 1 into column number 2. So now for 6th year it will be the 15,522.5. then for the next 1609.35, and for year number 8, so that is a 17,960.5. so this is present value. Column number 3, that is maintenance cost into present value with the discount rate. Then we know the summation of a maintenance cost, so we can say the cumulative maintenance cost. So here we are calculating for this maintenance cost with cumulative. So for first it will be the 0, then 0 plus 4545, so we will get that 4545.5, then 4545.5 plus this, so we are calculating cumulative maintenance cost, plus 8264, so that will become 12,809.5. similarly this plus 11,260, so it will get a 24,079. similarly you can calculate cumulative further, so I will write directly value here, so that will save the time and you can make the calculation. Similarly for the next year it will become 53,261.5, then 70,196.5. this is a cumulative maintenance cost, and for last that will be the 88,157.0. so you know that this is a cumulative. 0 plus 4545 you will write here, 4545 plus 8264, this is a then 12,000 plus this 11,269, that will be 24079. Likewise, you can calculate the cumulative maintenance cost. Now we know that the purchase price minus scrap value, so C minus S. In the last problem we have seen how to calculate. C is a capital cost, so capital cost what is given in the problem, it is a 50,000, and scrap value is not given in the problem. So C minus S, scrap value we can consider as 0, so this will become as it is, or written as it is, that is a 50,000. So here we can write a 50,000. So similarly I will write in short 50k, 50,000 remaining as it is, because there is a no scrap value for this problem is given. If the scrap value or salvage value is given, then you can take a scrap value or salvage value, that is a S. Now next is a total cost plus this C minus S. Total cost we are calculating, so that is C minus S, this column. So I will write a column number, suppose 4, column number 5. So column number 5 C minus S plus summation of F of T. So this is column number 4. So here total cost is nothing but column number 4 plus column number 5. C minus S, this is column, and summation F of T. So this is a here 0 plus 50,000. So that will become, I will use another color. So that will become 50,000 here. Now here 4545.5 plus 50,000, so that will become 54,545.5. Similarly here this plus 50,000, so that will become 62,809.5. Then next is 74,079. Then next I will write directly the answer, 87,739. Then here 1,03,261.5, and next is I will directly write 1,20,196, then 1,38,157. So these are the column number 4 cost, column number 5. So that is the total cost. Now we know how to calculate the average annual cost. So for calculating the average annual cost, we are dividing the n. The n is a number of year. So here we are calculating for first year. So 1 upon n into total cost. So total cost here we know this. So 50,000 divided by 1. So this will become a 50,000. Then here 54,000 divided by 2, because we are calculating for the second year. So this will be the 27,272.5. Similarly here divided by 3. So that will be the 20,936. Here divided by 4. So it will be 18,519.75. Here divided by 5. So that will be the 17,547. Then here divided by 6. So here 17,210. Then here divided by 7. So you can make a calculation in the pointer. I have not written the point. So here that may be the 25, but you can make it in the point. So divided by 7. So here 17,170.92. And then in the last 17,269.62. So these are the average annual cost. So now we know the rule. So what is the rule? So when up to the which point the cost is reducing. So for first year, so this is average annual cost 50,000. It is reduced to 27,000 for second year. Again it is reduced to 20,000. Here again reduced to the 18,000. Again reduced to the 17,547. Again reduced to 17,210. Again it is reduced to the 17,170. Okay, from 210 it is reduced to the 170, but after this year it is increasing because it is 269. So this cost is increasing after the 7th year. So we can replace this machine after 7 year. So because after 7 year this cost is going to increase 170 and here 269. So replace machine or replace that item after 7 year. So this is the answer, because after 7 year this cost is going to increase. So replace this item after 7 year. So this is the solution of the problem with the discount rate or time value changes rate.